Hello everyone, my name is Ruofan, and today I'm going to talk about gravitational slingshot, and it can also be called gravitational assist. As we all know, in the long history of human beings, it's always our dream to look deep into the universe and see what is happening outside the world we live in. And today, gravitational slingshot, this is a method that we can exploit to speed up our spacecraft and to change the directions of our spacecraft and help us to fly further and explore more in the universe. And now, let's start. So let's assume that there is a massive planet such as Jupiter. Yes, Jupiter. And this the craft fly by and close and fly away. And at first there's the initial velocity, and there's a final velocity, and the Jupiter, it has its own velocity. So now we can think about some equations to solve this situation. First is the VI. The VI is the absolute velocity. It should equals to the velocity of the Jupiter plus the velocity of the spacecraft relative to Jupiter. And this is relative. This is relative velocity. But please pay attention that here they are all vectors, so it has direction issues. And there's a theme. The final velocity it should equal to Vj plus the velocity relative to the Jupiter. And at last, under the Jupiter reference systems, the energy should maintain the same. So the kinetic energy at first should equal to the kinetic energy at last. Oh, sorry, here. This should be, this should be VRI. The initial velocity relative to Jupiter. Yeah. F squared. But as we all know, and I mentioned before, they are all vectors, so there are some angle issues, and we cannot directly solve these three equations because we don't know, such as the angle between VI and VJ and VF and VI, and we don't know any angle, but we can just consider a very special situation. That is, when there's one day, if we can control the direction very, very well, and we make the VI and VJ is in the opposite direction, and VF is in the same direction of VJ. And now the three equations can be changed into these ones. VI should equals VRI minus VJ. And as mentioned before here, although there's plus, here's plus, but they are all equations. And now we think they're all vectors, and now we think about the direction issues. So here it should be minus, and the VF equals VRF plus VJ, and VRI equal minus VRF. And we saw these three equations to obtain the VF equal VI plus twice VJ. And now we can see VF is much bigger than VI. Yes, we obtain a velocity twice the velocity of the Jupiter. So if here's our Earth, and outside our Earth we get Mars, but Mars is comparatively small. So here we have Jupiter, and outside Jupiter we have Saturn, and outside the Saturn, we still have the Uranus, and outside the Uranus, we have Neptune. We have Neptune. So each of the planets we can have a gravitational slingshot, and it can help our spacecraft speed up and change the direction to the direction we want. And then we can obtain enough energy to fly out of our solar system. So at last, let me give you a brief conclusion. Today, we basically talk about the gravitational slingshot, and the function is to change the directions and the magnitude of the velocities. And the significance of the topic today is it can save a lot of fuel and energy. And it makes it easier for us to explore the universe because we can easily give the spacecraft enough speed to fly out of our solar systems and see what is happening in the universe. That's all I want to talk about today. Thanks for your listening.